So this is the 2017 AP Calculus free response, question number 6. And I wanted to go ahead and actually show you the problem sheet on this one. We've got a table where g and g prime values are, so x, -5, g of x would be 10. And then we've got a graph of h. So I'm going to be referring to these, but I probably won't pull the sheet back out for you to see them. So you just need to follow along. We're going to be using this table, and we're going to be using this graph and kind of have to figure out the slope at certain parts of the graph of h. So the function that we start with, f of x is cosine of 2x plus e to the sine of x. And part A says, find the slope of the line tangent to the graph at x equals pi. Well, to get a slope, we're going to have to take a derivative. So f prime of x is going to be, all right, the derivative of cosine 2x would be minus sine 2x times the derivative of that inner function, so times 2, plus e to the sine x times the derivative of the exponent sine x, which would be cosine x. So to make this a little nicer, we would have f prime of x is equal to minus 2 sine 2x plus cosine x e to the sine x. So the slope at pi is going to be f prime of pi. We just want to plug pi in for x. So that's -2 times the sine of 2 pi plus cosine of 2 pi times e to the sine of 2 pi. Okay, so the sine of 2 pi is 0. Right, so that all is just going to go to 0. And this would be e to the 0, this part, because sine of 2 pi is 0, e to the 0 is 1. Cosine of 2 pi is 1. So, excuse me, that's not the sine of 2 pi, it's the cosine of pi. All right, I'm plugging pi in, I didn't mean to put 2 pi. So the cosine of pi is -1 times e to the 0, which is 1, so the slope will be -1. Okay, so cosine of pi, again, -1. You just have to remember that from your unit circle. Now, part B, we're going to refer to the graph of h. Okay, we're going to have to get the slope here of that line. You know, so you'll do just y2 minus y1 over x2 minus x1 there. The question asks, let k be a function defined by k of x is equal to h of f of x. Find k prime of pi. Well, k prime of x, so think of this as a chain rule, all right? It's going to be h prime of that f of x is the blob. So h prime of the blob, or the inner function, times the derivative of the inner function, so times f prime of x. So k prime of pi will be h prime of f of pi times f prime of pi, which we already figured out, right? That's -1. Okay, so what is f of pi? Well, we would need to stick f of pi into x up here. So that's the cosine of 2 pi, which is 1, plus e to the sine of pi, which is 0. Okay, so f of pi is just going to end up being, well, let's think about that for just a second. So the cosine of 2 pi is 1, plus e to the 0 would be 1, so that would be 2. So f of pi is 2, excuse me there. So that's going to be h prime of 2 times negative 1. Okay, remember f prime of pi is negative 1. We got that in the last one. All right, h prime of 2 is the slope of h at x equals 2. So you're going to look at the graph, okay? The slope is going to be y2 minus y1, so that's going to be negative 1 minus 0 over x2 minus x1, so that's going to be 3 minus 0, which is negative 1/3. So now that we've got that, h prime of 2, negative 1/3 times negative 1 is 1/3. Pretty convoluted problem there. You have to do an awful lot to go through that. I think this is an important problem. I do think it was kind of a hard one. Certainly not part A, but parts B and C kind of were. All right, pause the video if you are still writing. Let's take a look at part C. So part C says m of x is equal to g of minus 2x times h of x. We want to find m prime of 2. All right, well, first we got to take the derivative of this thing. So get m prime of x. All right, this is a product rule. The first, g of minus 2x. So we're going to be using the table for g in this one. Times the derivative of the second, h prime of x, plus the second, h of x, times the derivative of the first, that's g prime of minus 2x, times the derivative of that inner function, which is going to be negative, did I forget to erase all that? All right, the second times the derivative of the first, so times negative 2. All right, so again, we're taking the derivative of negative 2x. That's the inner function. So negative 2. Okay, so what is m prime of 2? So that's g of, if I plug 2 in there, that'd be negative 4, times h prime of 2, plus h of 2, times negative 2, that's the negative 2 right there, times g prime of negative 2 times 2, which would be negative 4. All right, what a mess. Okay, g of negative 4, this is from the table. All right, g of negative 4 is 5. H prime of 2, we just figured out in part B, that's negative 1/3. H of 2, we're going to have to read the graph, and that's going to be negative 2/3. And then we have times negative 2, and then g prime of negative 4 is in the table. That's negative 1. So that's negative 5/3 plus, all right, negative times negative times negative will be negative 4/3, which is negative 9/3, which is negative 3. Goodness gracious. All right, doable, but easy to get lost there in the mess. I think I can squeeze part D in here, and this will finish the 2017 test. It says, is there a number c in the closed interval from negative 5 to negative 3 such that g prime of c is equal to negative 4? Well, if it's continuous and differentiable, it would be due to the mean value theorem. So let's get the secant line slope for that interval negative 5 to negative 3. So it would be, that's going to be, of course, a y2 minus y1 over x2 minus x1. That's g of negative 3 minus g of negative 5 over negative 3 minus negative 5. All right, g of negative 3 is in the table. That is 2. G of negative 5 is in the table, and that is 10 over 2. So that is negative 8 over 2, which is equal to negative 4. So the secant slope is negative 4. So we know that the tangent slope has to be negative 4 as well. So the explanation you can write is, since g is differentiable and continuous, the mean value theorem states that at some point C, the slope of the secant line is equal to the slope of the tangent line. Well, I used every bit of that board there. Sorry about that. All right, so that's the mean value theorem. A good chance you're going to have to deal with the mean value theorem, probably also the intermediate value theorem somewhere on the test. That finishes that finishes 2017 free response number 6. And we'll talk to you next video.